Okay, guys, in this video, we are going to review integration in polar coordinates. How do I know this is going to be polar coordinates? So I can see that there are circles. So anytime we have some kind of circular region, and in this case, it's between two circles. So this would be radius 1, because this is radius squared, and this will be radius 4. Okay, so this is between two circles, and also they say that this is the second quadrant, right? So that's going to be different in terms of the limits. So we have this 1 through 4, here 1 through 3, 4. Just trying to draw the region for you. So this will be something like this, and then this will be a circle of radius 4. And then we stop in the second quadrant, right? So we only have second quadrant here. Yeah, so this is going to be the region between two circles, and the region is in the second quadrant. So in terms of the limits of integration, how are we going to set them up? So usually we'll have dr inside, d theta outside. And think about fixing a theta. So if I fix a theta, so which means that I fix the angle, how does the distance to the origin change? So from here to here, right? So this would be this right here. So the r limits are going to be from 1 to 4. Now, in terms of how theta changes, theta will change. Well, you need to all know the trig circles. So like this would be 0, this is pi over 2, this is pi, this is 3 pi over 2, and then back to 0 or 2 pi. So this is also going to be 2 pi. So for example, if this was the first quadrant, you will be integrating from 0 to pi over 2. If it's the second quadrant, pi over 2 to pi. Third, pi to 3 pi over 2. Fourth, 3 pi over 2 to 2 pi. So because I have second quadrant, that means that my limits are going to be pi over 2 to pi. Now, what do I have to integrate? If it's area, then you are integrating 1. However, when you switch into polar coordinates, you're going to add an extra factor r, which is called the Jacobian, and this is from converting from rectangular to polar coordinates. I always tell my students to remember the pirate. So the pirate says r. Okay, so that extra r that seems like comes out of nowhere should be there. And because this is not area, we are actually integrating 81 minus x squared minus y squared to the power 3 halves. So this is not just going to be 1r. So what is 81 minus x squared minus y squared? So if you factor the negative, you're going to get x squared plus y squared in parentheses. And that's going to be r squared. So you need to know that for polar coordinates. So that's just a reminder, x squared plus y squared equals r squared. If, however, you have to integrate something like x or y and it's not squared and you don't have x squared plus y squared, then just remember that every x will change to r cosine theta and y will change to r sine theta. Now, we do not have to do that here, because here we do have something that can be expressed in terms of x squared plus y squared. So we are going to be integrating 81 minus r squared, and then the whole thing is to the power 3 halves. Okay, so let's see if we can compute that. Let me just fill out the limits first over here before we proceed. So here we go 1 through 4. Here we're going to have 81 minus r squared. The whole thing is to the power 3 halves, extra r. Don't forget that. Okay, so the next thing is the actual evaluation of the integral. So let's see if we can do that. Now notice that this integral is splittable, as it is the case in most cases that I consider when it's polar coordinates, because the limits are numbers and the function itself doesn't have a theta. So we can certainly split this apart into pi over 2 to pi d theta. And then we multiply that from 1 to 4 integration, 81 minus r squared to the power 3 halves with extra r dr. Okay, so from the first integral, that will just be pi over 2, right? Because we just subtract pi minus pi over 2. Now, for the second integral, you do have to do a substitution. So let's carefully do the substitution. So we're going to have the substitution equal to whatever is in the power, right? So this is going to be your u equals 81 minus r squared. Now, What is the most common mistake I see here is when people put du, they're going to say that's 2r dr. That is incorrect because you do have a minus here in the front. So don't forget that minus there. So from here, by dividing both sides by negative 2r, I will solve that and I find that dr equals du divided by negative 2r. Okay, so what that will make this integral. So let me do this on the side here, and then we're going to substitute the limits. So instead of 81 minus r squared, I'm going to put u. So this will be u to the 3 halves. Instead of r, I'm not going to put anything, just keep it as r. But instead of dr, I will put du divided by negative 2r. Now, notice that r and r over here will cancel. That's great. But also the negative 1/2 will go in the front. So because the 2 is on the bottom, do not bring the 2 up and don't think this is 2. It's 1/2. Negative 1/2. Now, how do we integrate something like u to the power? So we add 1 to the power. So this will become u to the power 5 halves. And then you're dividing that by 5 halves. Okay, so dividing by 5 halves is the same as multiplying that by 2/5, right? So this will be 2/5. Okay, and then this will become u to the power 5 halves. Okay, so 2 cancels. So looks like that's going to be negative 1/5. So I'll just write that over here. So negative 1/5, and then it'll be u to the power 5 halves. But what is u? Do not ever forget to go back to whatever you were when you were doing the substitution. So u was 81 minus r squared. So that will become 81 minus r squared to the power 5 halves. And now we can substitute our limits, which were 1 and 4. Okay, so let's see. So let's first substitute 4. So we will get, let me move that negative 1/5 and combine that with pi over 2. So that will become negative pi divided by 10. And then we get 81 minus r squared. So 81 minus 4 squared. So 81 minus 16, that's 65. So that will become 65 to the power 5 halves. Subtract, now substitute 1, that's going to be 80 to the power 5 halves.